Hello students, and welcome to today's lecture, which is going to be on carboxylic acids. For today we'll go ahead and briefly talk about the production of carboxylic acids, and then we'll go ahead and talk about some reactions with carboxylic acids, and then finally we'll end up closing with the reduction of carboxylic acids. Okay. And the first thing that I want to go ahead and do to talk with you guys about is that we do have a couple of ways to make carboxylic acids, okay? And the most common way that we've kind of gone over before is that we can go ahead and essentially oxidize an alcohol is the first and probably most common way for us to sort of make a carboxylic acid. And okay, let's see, this one has 1, 2, 3. And the idea is that we go ahead and we oxidize this one right here. And when we oxidize this the first time, what'll end up happening is that we'll go ahead and make a aldehyde molecule. Okay, and that's what this one here is going to end up being, because now this one has a double bonded oxygen to the carbon right here. So this is usually step one. And then we can go ahead and take our aldehyde. And when we take that, we'll go ahead and take it and we'll further oxidize it again, usually under reflux. And we will end up making a CH3COOH. Okay. And when that happens, we end up getting our carboxylic acid here. Okay, and that's one way, that's the way that we've went ahead and been making these in the past, and we can use either potassium dichromate, or we can end up using potassium permanganate. Both of these are both oxidizers that we can go ahead and oxidize our alcohols. We have a second way that we can go ahead and oxidize these alcohols, and it can be made from a nitrile group, okay? And this nitrile group in particular is kind of in a precarious position, so it can end up being broken apart just a little bit. And when we have a nitrile group like this, and we add a strong acid and water to it, we can end up turning it into a carboxylic acid. So this is just a secondary way that we can go ahead and make carboxylic acid using a nitrile group as our starting point. Okay. Next, we're going to go ahead and talk about some reactions with carboxylic acids. And these are all kind of just another way of drawing it. Or they're kind of easier to just go ahead and draw them out. And to show you guys how this works is that we need to go ahead and treat most of these as if they are going to be acids. Okay, so a carboxylic acid is a compound, and we'll use this one right here, where we have this kind of a structure here, and this hydrogen right here is potentially going to be lost. Okay, so this hydrogen here is the kind of like the proton that this particular molecule can work. Now this carboxylic acid, it does have two resonance structures. It can be drawn either way. Or you can go ahead and say that it has the full resonance structure. The more accurate view is probably closer to here where we have a partial bond in between both of these at the same time. And the hydrogen kind of sits in right there. Okay, and this is what a carboxylic acid is. That we essentially have this group right here where we have this double bond oscillating in between here, or that it's just kind of shared in between here. And we have this hydrogen group that can come off. Now, the first one that we're going to look at, the first type of reaction, is going to be the reaction with an alkali. Okay, so we're going to go ahead and do CH3, CH2, COOH. Okay, and this right here is the acid. And when it combines with an alkali, and we're going to go ahead and use sodium hydroxide, just because that's our most common alkali that we use, we're going to end up making, essentially, NaCH3, CH2, COO. So we're going to make sodium, and this is an acetate. This would be propionate plus water. Okay. So this is a typical acid-base reaction where we have an acid and a base. They come together, they make a new salt, and they make water. Okay. The next is going to be reactions with metals. Okay. And usually when we talk about this, we're going to go ahead and talk about the metals that are more reactive than hydrogen. A brief reminder that we do have a reactivity series. And when you have that reactivity series, you have to remember that the metals are going to, not all the metals are going to react as readily as some of the others. So for instance, if we use gold here, which is a very unreactive metal, we would have no reaction. Or we could use a metal that's slightly more reactive, that's higher on the series. And we can say like magnesium. Magnesium's fairly reactive. And what will happen is that the magnesium is going to go ahead and replace this hydrogen here. Okay, and we will end up getting a case where we have the magnesium and it's replacing the hydrogen altogether. So we're going to end up making hydrogen gas. Okay, so whenever we have a super reactive metal and it's reacting with this this acid here, we'll kick off some hydrogen gas. And the last type of reaction that we can have is going to be a reaction with a carbonate. And let's go ahead and spell carbonate wrong because we know that R's exist. And a carbonate is basically going to be a compound that ends up having the CO3 ion. And we'll do sodium carbonate, or sodium bicarbonate as it's typically called. And you guys are already familiar with this because this is essentially kind of similar to a vinegar volcano. We're going to end up making the same kind of salt. So we'll end up making the NaCH3, CH2, COO. Okay, so we make the same salt as we did before. We're still going to go ahead and make some water, because what's going to happen is that this carbonate is also going to end up losing an oxygen. And if this is losing an oxygen because of this reaction, then we're going to end up making also carbon dioxide. Okay, so when we have an organic acid or a carboxylic acid and a carbonate, we're going to end up making the same salt as we did before. We'll make some water, because, acid and base, and this is essentially acts as a base. And we'll also make some carbon dioxide. Okay. Next, we're going to go ahead and briefly talk about the reduction of carboxylic acids. And carboxylic acids can be reduced with using this molecule right here. This is tetrahydroaluminate, okay? And Li, so we have lithium, aluminum, and notice that we have these 4 hydrogens that are right here, okay? And hydrogen, whenever it's at the end of a molecule, that means that it's kind of acting as a non-metal. And notice that it's combined with other metals right here. And we know that hydrogen likes to act as both a metal and a non-metal. Okay, so in this case, it's going to get to do its job of being able to reduce this here. And what you'll notice is that when we reduce it here, what we'll end up doing is that we'll go ahead and reduce it down to its corresponding alcohol. And in fact, whenever we have a hydride acting with one of our organic molecules here, we're going to go ahead and think that it's probably going to end up reducing our molecule. So remember, before we took our alcohol and we oxidized it, we can also go the opposite way and we can reduce it as well. Okay, that's going to go ahead and close today's lecture on carboxylic acids. And remember to stay lazy.